Have you ever really stopped to think about how the crazy complex gadgets we use every day are actually put together? We're not talking about just a few parts here and there. We're talking about thousands of them, all assembled at mind-blowing speeds with insane precision. Well, the secret to all of this, the real magic, lies with a totally unsung hero of the assembly line. It's the one thing that makes this whole high-speed symphony possible. So, let's dive in.
Just take your smartphone for a second. Inside that sleek case is an entire universe of technology. It's packed with well over 1,000 microscopic components, resistors, capacitors, tiny little IC chips. Every single one of them has to be placed perfectly or the whole thing just doesn't work. This isn't just a puzzle of complexity, it's a massive challenge of scale. And when I say scale, I mean it's just mind-boggling. Get this, modern pick-and-place machines are moving at absolutely blistering speeds, placing up to 100,000 of these little components every single hour. That's almost 30 parts every second. The placement head is literally moving faster than your eye can even track.
So that brings us to the big question, right? The machine is ready to go, it's moving at lightning speed, but how in the world do you deliver thousands of different, tiny little components to that exact pickup point, at the exact right millisecond, without a single mistake? How do the parts themselves even begin to keep up with that pace?
Okay, so here's what we're going to do. Over the next few minutes, we're going to break this all down. We'll start with that high-speed challenge. Then we'll meet the hero of our story, the SMT feeder. After that, we'll look at all the different types, the incredible precision you need to set them up, and finally, how you pick the right one for the job.
So, the answer to that high-speed challenge? It's a device called the SMT feeder. It might not be as famous as the giant robotic arms it works with, but believe me, it is the true unsung hero of any modern electronics assembly line.
So what is it exactly? Well, an SMT feeder is basically a precision mechanical device, and it has one critical mission: to reliably and systematically take components from whatever packaging they're in, whether that's tape, a tray, or a tube, and present them perfectly to the pickup head again and again and again.
And look, you just can't overstate how important these things are. They are the absolute backbone of automated, high-speed production. The stability of the feeder directly impacts the quality of the placement. Any little jam or misalignment can bring the entire line to a screeching halt. And those crazy high yield rates of over 99.5% that modern factories need? That's just impossible without a high-precision feeder that can do its job with a repeatability of plus or minus 0.05 millimeters. It's that precise.
All right, so not all components are made the same, right? They come in all sorts of different sizes, shapes, and types of packaging. And that's exactly why there isn't just one kind of feeder. Nope, there's a whole team of specialists, and each one is designed for a very specific mission.
Let's kick things off with the most common one you'll see, the tape feeder. As you can probably guess from the name, it handles components that are packaged on these long reels of tape. This thing is the absolute workhorse of the industry, responsible for placing the vast majority of parts in any high-volume factory. I love this analogy. Think of the tape feeder as a high-speed ammo belt for the pick-and-place machine. It's used for over 80% of all standard components, your basic resistors and capacitors. The feeder's job is to precisely peel back a tiny cover film and advance the tape one little pocket at a time. Now, the traditional mechanical ones are super reliable, but the newer electric versions use servo motors for even faster, more precise feeding. They're perfect for the most demanding, highest-speed production lines out there.
Okay, so tape feeders are awesome for all those small, standard parts. But what happens when you've got to place a big, sensitive processor? Or maybe a bulky, weirdly shaped connector? Yeah, those definitely aren't going to fit on a tape.
And this really gets to the heart of the trade-off. On one side, you've got tape feeders, which are all about raw speed for small parts in huge production runs. And on the other side, you've got tray feeders, which prioritize protection and flexibility for those bigger, more specialized components. It's a classic case of choosing between speed and specialty.
This brings us to the tray feeder. You can kind of think of this one like a precision vending machine. It's the one that handles those large, odd-shaped, or really sensitive components like ball grid arrays or quad-flat packages with their super delicate pins. These parts come in these industry-standard protective trays. Now, they're slower for sure, but tray feeders are absolutely essential for things like prototyping, low-volume production, and especially in high-reliability fields like aerospace and medical devices.
And that team of specialists doesn't even stop there.
For parts that are packaged in rigid tubes, like certain integrated circuits, you've got stick feeders that use vibration or just gravity to slide each part into place. And then, on the total opposite end of the spectrum, for really simple, low-cost parts, you might see a bulk feeder that basically just scoops components out of a hopper. They're not very precise, so you don't see them as much in today's high-tech world.
So, we've got our feeder picked out. Awesome. But getting that perfect pickup every time, well, it's not as simple as just plugging it in. There's this kind of secret language of precision that operators have to speak, and it involves making tiny adjustments measured in milliseconds and micrometers.
Yeah, setting up a feeder is truly an art of fine margins. The part height setting has to be perfect. Too high and the solder connection is weak. Too low and you could actually damage the board. Then you need a suction delay, a tiny pause, we're talking 25 to 200 milliseconds, just to make sure the vacuum has a solid grip before it lifts. And then there's a similar put delay to stop the part from getting blown away by the puff of air that releases it. Every single one of these parameters, especially that central pickup coordinate, has to be dialed in perfectly.
And if you get it wrong, the consequences are immediate. This quote from an industry source really says it all. A simple misplacement was caused by a push delay that was too short and the wrong part height. A push delay is a lot like the other delays we just talked about. It controls the timing of the feeder mechanism itself. It's just a perfect example of how a few milliseconds, or a fraction of a millimeter, can be the difference between a perfect circuit board and a useless one. Okay, we've seen the what and the how, so now let's put it all together. Choosing your champion feeder, really, it's all about understanding what you need to do and matching the right tool to the task at hand.
This simple table pretty much breaks it all down. If your number one priority is maximum speed and efficiency for mass production, well, the tape feeder is your champion, no question. If you're dealing with delicate, large, or custom parts, or maybe you're just working on prototypes, the tray feeder is the clear winner there. And if your absolute bottom line is the lowest possible packaging cost for really simple components, then a bulk feeder might be an option to consider.
And this technology is not standing still, not by a long shot. The future is all about smart feeders. We're talking devices that are packed with sensors and communication modules. They can count components in real time, scan barcodes to make sure you're not loading the wrong reel of parts, and feed all that data directly into the factory's main system. This allows for full traceability, which is absolutely critical in high-stakes industries like automotive and medical manufacturing. So it's pretty clear that SMT feeders are way more than just simple accessories. They are precision instruments that are the foundation for the speed, the accuracy, and the stability of all modern electronics manufacturing. But as we look ahead, we're left with a really compelling question. As electronic components keep shrinking down to near invisible sizes, are the incredible mechanical feeders we have today actually going to be enough for the technology of tomorrow?